it says, according to food labeling laws, a certain fast food cheeseburger has 750 calories, but we suspect the actually calorie content is higher. We plan to randomly purchase 36 of these cheeseburgers at locations around the country and have them measured for calorie content. Am I on the right page? Because you know me, I go to the wrong page sometimes, right? All right. So if we want to make our null hypothesis, we could just basically say, hey, mu is equal to 750. Okay. I mean, I'm just creating Greek letters up here. And then our alternative is we think that mu is greater than 750. So burger place claims 750 calories. You're pretty like, you know what? I'm either drying my pants on hot and they're shrinking, or all these cheeseburgers I'm eating have more calories, meaning you're getting chubbier. All right, so calculate the mean and the standard error. Okay, we've done these. I feel like we've just done these in one. So the mean is the 750 that they claim, and then the standard error. Ooh, now we got to change up things a little bit. All right. Let's see. Where are we getting this information from? Standard error. Why are we saying it's 100? We plan to randomly purchase 36. Fast food suspect higher. Is there something I'm missing here? Oh. So you have a standard deviation they gave you. So remember, standard error is standard deviation over the square root of n. So they gave you standard deviation being 100 over square root of 36. So that comes out to roughly 16.67. So we'll just round this to 17. Okay? All right. So we've done this before, this kind of stuff. I'm pretty sure. So let's create our normal distribution. So we're going to say that the 750 is here. We rounded it to 17 to make it a little more friendly. So this is 767. Add 17 to that. So 4, carry the 1, 7, 8. 784. If we go downward, we're going to go to 733. And 17, let's see, minus 17, that's 6. That's 1. 716. All right, so that's basically our normal distribution based on this to 2 standard deviations. I could have went to 3. All right. Now it says, let's assume our random sample produces an average calorie of 747. This is for number 4. So 747. So 747 is right about there. Is this strong evidence to favor our null hypothesis? Is it favoring that we're bigger than 750? I mean, is 747 bigger than 750? No. So not strong evidence. It's close to the mean. Close to mean. Not even greater than the 750. Okay, so there's really not evidence there. And then it says we want to use our graphing calculator. So that's Desmos. Don't use the normal CDF. All right, so let's jump on our buddy, the Desmos family. All right, so normal CDF or normal distribution. We're going to base this on 750. Standard error is 17. And then I can draw it. So that's what my normal distribution looks in this place. And then we haven't done this in a while, so we have to make sure we do this okay. So we want to know, use our calculator to find the percentage of normal distribution that is to the left of 747. So we want to go to the left. So 747 is, right in here. So we want to be the left of that. So then remember, I'm going to go period, and then I'm going to go, I have to go back because I've been a couple weeks since we've done this. Functions. And we're going to go to inverse CDF, I believe. Is it inverse CDF? I don't think it's inverse CDF. I'm sorry. I'm losing my mind on this stuff. I apologize. Let's see. Normal distribution, T distribution, poison, P. Oh yeah, the inverse CDF should work. And so no, that's not it. That's right. We do it this way. I'm sorry. So we can then plug in our 747 here. And we want to the left. So we're getting roughly 42, roughly 43% of the area under the curve is underneath the 747. Sorry, it took me a minute to remember that. Okay. So the hint that they have kind of on this one says, that was number 5, right? Yeah. This is the p-value. Okay. So this is the p-value, that 0.42 or 0.43. That's your p-value then. Okay. Assume that a random sample produces on average calorie count of 771. Is this strong evidence to go against our information? Okay, so we're saying they found that these cheeseburgers are 771. So 771 is somewhere in here. Okay, this is a bit better. A bit better. But let's face it, we're only like a little bit more than one standard deviation above, but it's not enough. It's not enough to really say, hey, we found evidence. It just happened to be maybe you had grabbed a couple of those sandwiches that they put 2 pieces of cheese on instead of 1 or whatever. Okay. Explain what type of type 2 error would mean in the context of this question. So a type 2 error says we failed to find strong evidence that these cheeseburgers average more than 750 calories when they do. Okay. So remember the type 2 error. Type 2 error was this. When we fail to reject the null when it's really true. So type 2 is fail to reject null that is really false. Okay, that's the definition of a type 2. So type 2 error, our null hypothesis was this, H naught, our value is 750. So we fail to reject the null. So this is saying that we are accepting this, but it is false. Okay? In this case, we're not, we failed to find strong evidence that the cheeseburgers average more than 750 calories when they really do. Okay? So that's your type 2 error. Okay, now, I know I did not give you the next page, correct? Well, I think we can walk through it if that's okay with you. Deal? Page 104? All right. It says, according to a recent government reports, 27% of the U.S. population has no health insurance. We believe the percent might be lower, but we want to select a random sample of 1,000 people to see. Okay? So problem number 8, our null is we're saying that we have 27% have health insurance, and we think it is lower than that. All right. So calculate the mean standard deviation. Okay, so the mean is 0.27. And then our standard error in this case, this standard error is going to be the one, probability over the sample. So you kind of have to plug in, I'm going to go 0.27, 1 minus 0.27, which is 0.73, divided by the 1,000 people. And if we do this math, we're going to come out to our standard error is 0.014. So number 10, if we wanted to calculate our normal distribution. So we have a mean here of 0.27. And then we're just go from there. If I add 0.014, I get 0.284. You get 0.298. If I go to the other way, if I subtract it, I get 0.256. Subtract it again, 0.242. Okay, we've only done normal distributions like 3 times this year, right? All right, which would produce stronger evidence in favor of our alternative hypothesis? So which one of these events is going to be better for us? Go to number 11. If we had a 0.22 or if we had a 0.24. Okay, which one's stronger evidence? Well, 0.22 is down here, right? And 0.24 is like right here. Which one's further to the left? Well, gee, stirrup, 0.22 is to the left of 0.24. All right, so 22% sample statistic is farther from the mean of 27%. So this is further away. And then number 12, explain why a random sample shows that 36% of the U.S. population has no health insurance, does not produce strong evidence in favor of our alternative. Hello, who do you got for me? I bet you he's coming. Was Winter here?
Yes.
Okay. Tommy's here. Mikey's here. Chance is here. Is Samantha here?
No.
We haven't seen Samantha. And I would just say, I'm not sure if as soon as I hand this back to you, this one kid, he's going to come walking in. But I don't know if he will. All right. This all can't be bad, being that a bunch of you got a coupon. All right. Tommy, you can blame me, okay? I'm your out. Okay. Chance, because you have me for homeroom, I'm your reason why you got in trouble. You're supposed to have Mikey, you can blame me anytime. Was it bad?
I knew it was, I forgot.
Oh, do you want me to cycle? All right. So explain why the random sample shows that 36% of the population. So number 12, they're saying 0.36. 0.36 on our chart is like way over here. Okay? The result is in the opposite direction. It provides evidence that the percent with no health insurance is greater than 27%, not less. So we were trying to test that people had less than that health insurance. And then if we ultimately decide to reject the null hypothesis in our study, explain what that means, we would find strong evidence that the percent without health insurance is below 27%. Okay? All right. My friends, I'm just going to tell you and you should be fine with this. I gotta just find where it's at. Um, so I would like, so come tomorrow, I'm gonna have an assignment that's gonna be given. Okay. It's just a review. But I'll tell you what the assignment's going to be. It's going to be page 107 and page 108. Okay? This is not, I am not assigning this for you to do before you get to class. This is what you would do in class tomorrow. And I will put a video later today on Schoology. I've told my sub that you have my permission to have your phone out watching the video to help you along with that. Okay. This is not due tomorrow. Okay. It's just this is what's being given for you. And then the nice thing is this kind of gives us a good place to pause before we go into spring break. Okay. I'm not going to give you a quiz on 6-4 to 6-7. I know most of you are probably crying yourselves asleep knowing that, but that's what it's basically going to take place tomorrow. Then I'll be back on Friday. Okay. Deal? Everybody happy? Awesome.